Good afternoon everyone, I am Astha Lutari from MTech IT 4th SAM and today we will discuss question number 6 of lab assignment 3. So our question is describe approximation and derive normal equation for the following. First is least squares approximation and second is polynomial approximation using orthogonal polynomials. First is least square approximation concept. Given a set of data points x1, y1, x2, y2 up to xn, yn, we want to find a function fx from a certain class, usually polynomials, that minimizes the sum of squares of the vertical deviations, which is known as errors, between the data points and the function. Let the approximation function be fx is equals to a0 plus a1x plus a2x square plus up to am up to the power x to xm. Objective: minimize the sum of squared errors. S is equals to summation I is equals to 1 up to n yi minus fxi square is equals to summation I is equals to 1 up to n yi minus summation j is equals to 0 to m aj xij square. Derivation of normal equation: we minimize s with respect to each coefficient ak by setting partial derivatives to 0. By this method, for k is equals to 0, 1 up to m. This gives us a system of m plus 1 equations, that is summation I is equals to 1 to n yi xik is equals to summation j is equals to 0 to m aj summation I is equals to 1 to n xi j plus k. These are called the normal equations of least squared approximations. Now the second part comes, that is polynomial approximation using orthogonal polynomials. Concept: instead of using the standard basis, that is 1x x square up to xn, we use orthogonal polynomials phi 0x, phi 1x up to phi nx with respect to a weighted function wx over an interval ab satisfying summation a to b phi I x, phi j x, wx dx is equals to 0 for I not equal to j. Common orthogonal polynomial include Legendre polynomial, weight is equals to 1, Chase-Bashev polynomial, Laguerre-Hermite polynomial, etc. Approximate function: let the approximation be fx is equals to summation k is equals to 0 up to n ak phi k x. Goal: to minimize the weighted square error. F minus Pn whole square is equals to integration a to b fx minus summation k is equals to 0 to n ak phi k x whole square wx dx. Derivation of coefficients, that is normal equations equivalent. Thanks to orthogonality, the coefficient ak are obtained directly. Ak is equals to integration a to b fx phi k xw and xdx upon integration a to b phi square k xw and xdx. These coefficients minimize the squared error in the least square sense and are essentially projections of fx into the orthogonal basis. Thank you so much for listening.